My name is Emma McKnight, and today we'll be going over question 4, part A, on page 201 of the Nelson Calculus and Vectors textbook. The question reads as follows. A rectangular pen is built with 1,200 meters of fencing. The pen will be divided into 3 parts using 2 parallel partitions. Find the maximum area of the pen. This is an example of an optimization question. Optimization is the action of making the best or most effective use of a situation or resource. In this case, we are looking for the maximum area possible for a pen that is built with 1,200 meters of fencing. Next, we will go over the key parts of this question. A rectangular pen is built with 1,200 meters of fencing. This part of the question tells us the shape of the pen as well as how much resources we have. In this case, it will be a rectangular pen and we only have 1,200 meters of fencing. This next part says, the pen will be divided into 3 parts using 2 parallel partitions. This tells us that the pen will be divided, so we won't have a square pen in order to get the maximum area. Find the maximum area of the pen. This tells us what we are looking for in the end of our question, which is the maximum area. Steps to success. First, I will draw a picture. Second, I will define the equation for maximum area of the pen. Third, I will define the perimeter of the pen. Fourth, I will get the equation to have a single variable. Fifth, differentiate this equation, and then using that, I will solve for maximum area. First, draw the picture. As you can see, I have drawn the picture as a rectangular pen split into 3 parts using 2 parallel partitions. Next, I have defined the variables. X will be the vertical components of this pen, and the Y's will be the horizontal components. The area is as follows. Area is equal to 3x times y. It is 3 times x times y because one of the small pens is 1xy, and we have 3 of the small parts, so we must multiply it by 3. As you can see throughout the whole presentation, I will be defining x as a blue and y as a pink. This will help keep everything in order and make it easier to understand. Next, the perimeter. The perimeter is 6y plus 4x. This is because there are 6 y's across the horizontal parts of the pen, and there are 4 y's including the outsides and the 2 partitions. Next, we will set y equal to an x equation in order to get a single variable. So, perimeter, as we know, is 6y plus 4x. If we set this to the amount of perimeter that we know that we have, we can then solve out to have y equal to an x equation. First, divide the entire equation by 6 to give us 200 equals y plus 4 over 6x. Next, we rearrange to get y by itself. So, y ends up being equal to 200 minus 2 over 3x. We can then plug this into our y value in our area equation. So, we get 3x times 200 minus 2 over 3x. We then expand out and get 600x minus 2x squared. This equation will be used to differentiate in order to get the maximum area. Now that we have an equation, we can get a graph. This graph shows us that the maximum area will occur when the x value is somewhere around 150. we know that it will be a big number, over 40,000. This will help us keep on track and ensure that we end up with the right answer. Next, we must take the derivative of the area equation. The derivative is the way to show the rate of change, which is the amount of which the function is changing at any given point. In this example, the derivative will be the area at any given value of x. So now we take the derivative of our area equation. So we take the exponent that was on the x, multiply it out here, so we get 1 times 600, and then we subtract 1 from the exponent of this x. And then in the second part, we multiply the 2 by the exponent of 2 that the x had, and subtract 1 from that 2, which gives us with 600x to the power of 0 minus 400x to the power of 1, which can then be further simplified to 600 as x to the 0 is equal to 1 minus 4x. We then solve out for x, which can then give us our y value. So we set it equal to 0 in order to optimize our area. 0 is equal to 600 minus 4x. Therefore, negative 600 is equal to negative 4x, which finally gives us 150 is equal to x. We can then plug this into our y equation. Y is equal to 200 minus 2 over 3x. So y is equal to 200 minus 2 over 3 times 150. And finally, y is equal to 100. We can then plug these values into our original area equation to get our maximum area. This is what the diagram of the pen will look like. We will have a total length of 300, as the partitions are each 150 meters. The separated parts of the length of the pen will be 100 meters each. So, finally, area is equal to 3xy. We plug in our x value and our y value, and we get 45,000 meters squared. Now we can check this with our graph. As you can see, at 150 meters for the value of x, we get 45,000 meters squared. This means that we got the correct answer. The maximum area of the pen will be 45,000 square meters. Thank you.